Welcome back to the deep dive. Today we're diving into language models and specifically how they can learn from their mistakes.
We're going to be looking at a research paper. It's called Physics of Language Models, Part 2.2, How to Learn from Mistakes on Grade School Math Problems.
So this paper looks at some new ways to help language models get better at reasoning, especially when it comes to math problems.
Yeah, so the paper starts off with a really interesting observation. It's this thing called regretful behavior in language models.
Regretful, like the model feels bad when it makes a mistake on a calculation or something.
Not exactly feel, it's more like they seem to know they made an error, while they're solving the problem. Imagine like a model is working through one of those multi-step path problems, and sometimes they kind of take a wrong turn, right? Like they might pick a variable to define before they even have all the info they need.
Yeah, okay. I've definitely seen that, even with some of the really advanced models.
Right, and so the interesting thing is it's like the model immediately realizes it messed up, like right after it writes it down.
So how do researchers know if the model actually knows it messed up?
They use this technique called probing. So basically, they analyze the model's internal state after it makes a mistake. And what we found is that they can actually predict whether the model knows it made an error, like even if the model was trained on data that was perfectly correct.
Wow, that's really interesting. So even if you don't teach the model specifically about errors, it still has some kind of built-in sense of when it's going off track.
Right, exactly. And this whole thing with the regret signal is so fascinating because it kind of hints that there's like a mechanism in these systems, even though they're super complex, that can actually like flag inconsistencies in their own reasoning.
So if a model can sense that it's made a mistake, is there a way to use that to help it self-correct?
That's exactly what the researchers wanted to know, so they developed this method called retry upon regret. It's basically like the model kind of hits a backspace button, and it regenerates a step if it senses it made a mistake.
So it's like giving the model a second chance to kind of rethink its approach in the middle of solving a problem.
Yeah, exactly. And this retry upon regret method, it actually did better than other standard techniques like beam search, where the model tries out lots of different paths at the same time.
Oh, that's interesting. So is it better to have the model focus on correcting the error it sees instead of just blindly trying a bunch of different options?
Yeah, it seems like it. Like when you explicitly acknowledge the error and address it, that's actually a better strategy for improving reasoning compared to just brute force exploration.
Okay, but this still relies on the model randomly coming up with the correct step right after it backtracks. It's not really learning how to correct the error itself.
You're right. With retry upon regret, it's more reactive. Like it helps the model avoid going too far down the wrong path, but it doesn't teach it how to actually fix the mistake.
So that's where this idea of retry data comes in.
Exactly. So the idea here is to actually train a model on data that shows how to correct errors, like directly. So what they did was create a data set of math solutions, but they intentionally put in incorrect steps. And then they showed the correct way to fix those mistakes.
Also, it's like they're showing the model how to go back and fix its work, like a student learning from corrected homework.
Exactly, like giving them a roadmap. And the results were kind of surprising. So models that were trained on this retry data, they actually performed way better than models that were trained on the same amount of data, but without any errors.
Wow, so it's actually more effective for the models to learn from mistakes than to only see perfect solutions.
Yeah, it really seems that way. And what's even more interesting is that these models, when they were tested, they rarely made any mistakes themselves, even though during training they had seen all these errors.
Oh, that's fascinating. So it really suggests that the models weren't just copying the corrections they were shown, but actually learning some deeper principle about how to correct errors in general.
Exactly. And that points to a key difference between like learning error correction as a skill versus just trying out multiple possibilities with something like beam search. With the retry data, it's like the models are getting a deeper understanding of how to actually course correct instead of just trying different paths randomly.
Okay, so if these results are so promising, could you just take any pre-trained model and fine-tune it on this retry data? Would that be enough to boost its reasoning abilities?
Well, that was the next step. So researchers tried fine-tuning using techniques like LoRA, which basically lets you efficiently update just a small part of the model's parameters.
So the idea was to try and get these new skills into the model without having to retrain the whole thing from scratch.
Right. But surprisingly, it didn't really lead to big improvements. It seems like error correction is actually a pretty complex skill, and it might need deeper changes to the model's architecture. or to the training process itself.
So you can't just sprinkle in some retree data on top and expect the model to magically get better at correcting errors.
Yeah, that's what it's looking like. It kind of highlights how complex error correction really is, and it shows that we need to do more research on how to really build it into the training process.
Interesting. Now, one thing I was thinking about is, getting real-world data that has errors and corrections, especially for something specific like math. It seems like that would be pretty hard to come by.
Yeah, that's definitely a challenge. So to deal with that, researchers looked at ways to create fake retry data from solutions that are already correct. And one method that worked surprisingly well was basically inserting random future steps as like fake mistakes, and then having the original step be the correction.
So they're basically making the model skip ahead and then forcing it to go back and fill in the missing steps.
Exactly. And even though it seems kind of counterintuitive, it actually helps the model learn a really important lesson, which is don't skip steps. Like even if a step seems obvious, it's still important.
Oh, I see. So they're trying to teach the model to be really thorough and pay attention to detail.
Right. And this method, even though it's not perfect, it actually did lead to some improvements in accuracy.
Wow, that's really interesting. So even if you create rep-tree data artificially, it can still help to improve the model's reasoning.
It seems that way, and this is especially useful for people who are working with limited data, because it means there are ways to make your model better at reasoning, even if you don't have a perfect data set of real-world errors and corrections.
Okay, so we've covered a lot of ground here. Can you maybe summarize the main takeaways so far?
Sure, so the first thing is this regret signal. It shows that language models can actually sense when their reasoning is going wrong, even if they weren't specifically trained on errors. And then there's the retree upon regret method, which uses that signal to let the model backtrack and try again. And then the third thing is retree data, which basically means training models on examples of errors and how to fix them. And this really seems to be key for improving their reasoning skills.
And then finally, even though fine-tuning existing models with retree data hasn't been that successful, there are ways to create synthetic retree data, and that can still be a useful workaround, especially when real-world data is hard to find.
Exactly. So all these findings, they really highlight how important it is to make error correction a central part of language model training. And they open up some really exciting new possibilities for building AI systems that are much more robust and reliable.
This has been a really fascinating deep dive, and there's even more to come. In the next part, we'll be taking a closer look at how these techniques were actually implemented, and we'll explore some of the nuances that the researchers uncovered. So stay tuned for part 2.
See you there. Welcome back. So let's dive a little deeper into this whole regretful behavior thing, that we saw in language models.
Yeah, okay. So can you remind me, how is this regret different from the model, just like making a regular mistake?
It's really about what's going on inside the model, during the problem-solving process. So when you train a model on correct solutions, it seems like there's this shift in its internal representations right before it's about to generate like an incorrect step.
So it's not just that the output is wrong. It's like there's something you can actually detect in the model's thought process as it's working.
Right, exactly. And that's what the researchers call regret. And they figured this out using this technique called probing, which is basically a way to analyze the model's internal states after each step.
So with probing, you can kind of see how the model is processing information step by step.
Yeah, exactly. And what they found is that the model's internal state, it looks very different when it's about to make a mistake compared to when it's on the right track.
Oh, that's really interesting. So does that mean there's like a mechanism inside the model that can tell whether its reasoning is correct or not, even if it wasn't trained specifically on errors?
Yeah, that's what it seems like, this whole regret signal. It's a really important insight because it suggests that even models that are trained on perfectly correct data, they still have this like inherent sense of when their reasoning is going off the rails.
Okay, I see. So how do the researchers actually use this regret signal to improve the model's performance?
Well, they came up with this method called retrieval upon regret, which basically uses that internal signal. So whenever the model's regret signal goes off, it triggers this retrieval mechanism.
So it's like the model gets a chance to stop and think things over again before it goes too far down the wrong path.
Exactly, and pretty amazing. Just the simple method, it actually led to better accuracy. It even outperforms some of those more traditional techniques like beam search.
Wow, that's impressive. But it still relies on the model to come up with the right step on its own, right, after it backtracks. So it's not actually learning how to correct the mistake.
Right, you got it. Retrieval upon regret. It's more of a reactive strategy. It helps the model avoid making things worse, but it doesn't teach it how to actually fix the errors.
So that's where the right tree data comes in.
Right, exactly. So the idea with retrieval data is to train the model on data that actually shows it how to correct errors, like directly. So the researchers created these data sets where they took correct solutions and they intentionally put in incorrect steps, and then they showed the correct way to fix those mistakes.
So it's like they're providing the model with examples of not just the right way to reason, but also the process of like recognizing and fixing errors.
Yeah, exactly. It's like giving them a roadmap of how to recover from mistakes, which is like super important for developing really robust reasoning abilities.
Okay, so what were the results like when they trained models on this retri data?
Well, the models showed some pretty big improvements in their reasoning accuracy. They did way better than the models that were trained just on the error-free data.
So showing the model those examples of error correction, it really made a difference.
Oh, yeah, absolutely. And get this, when they tested these models, they hardly ever made any mistakes themselves, even though during training they had seen a ton of errors.
Wow, that's really cool. So it really suggests they weren't just memorizing the specific corrections, but actually learning something more general, like about how to correct errors, period.
Right. It really does. And this kind of points to the idea that error correction, it's like a skill that can actually be learned. And it's like a key ingredient for developing these more sophisticated reasoning capabilities in language models.
So if you're getting such good results with this retri data, why not just take like any pre-trained model and just fine-tune it on this retri data? Would that be enough to kind of boost its reasoning skills?
Well, yeah, that's what you'd think. So the researchers, they tried doing that. They used techniques like loraris, which lets you just fine-tune a small part of the model's parameters. So it's very efficient.
So they were hoping to kind of slip these new skills in without having to retrain the entire model from the ground up.
Yeah, exactly. But the results were kind of surprising. Fine-tuning on retri data, it didn't really lead to any significant improvements.
Oh, wow. So even though the retri data idea worked well, when they were training models from scratch, it didn't translate well to fine-tuning.
Yeah, that's what it looks like. It seems like error correction is a lot more complex than we initially thought. It might require some deeper changes to the model's architecture, or maybe even the training process itself. You can't just like slap it on afterwards.
So it's like error correction needs to be built into the foundation of the model, not just added on as an afterthought.
Right. It really highlights how complex this whole thing is, and it shows that we need to do more research on how to properly integrate it into the training process. If we want these models to be really good at reasoning, we need to rethink the way we approach model architecture and how we train them.
That makes sense. Now, earlier you mentioned that one of the big challenges is that real-world retri data is really hard to find, especially for something like math.
Yeah, for sure. Getting real-world data with errors and corrections, it's a huge pain. So to deal with that, the researchers started looking at ways to create this like synthetic retri data, from data sets of correct solutions.
So instead of using real-world examples of mistakes, they tried to create artificial ones. How do they do that?
Well, one approach they used was to take these correct solutions, and then they would insert random future steps, like as these fake mistakes, and then the original step would become the correction.
So they're like intentionally making the model skip ahead and then forcing it to go back and fill in the gaps. It's kind of a weird idea.
Yeah, it sounds kind of counterintuitive, but it actually forces the model to learn something important, which is don't skip steps. Like, even if a step seems super obvious, it's still an important part of the process.
Oh, I get it. So it's like teaching the model to be really careful and thorough.
Exactly. And what's crazy is this method, even though it's not perfect, it actually did lead to some improvements in the model's accuracy.
Wow, that's fascinating. So even this artificial retri data, it can still be helpful.
Yeah, it seems that way. And this is especially useful for people who are working with limited data, because it means there are ways to improve your model's reasoning, even if you don't have this perfect data set of real-world errors and corrections.
Okay, this has been a really interesting discussion. Can we maybe just summarize the key takeaways from our deep dive into regret and retri data so far?
Sure. So basically, the discovery of this regret signal, it shows us that language models, they have this built-in sense of when their reasoning is going wrong, even if they weren't specifically trained to detect errors. And then we have this retri upon regret method, which uses that signal to let the model kind of backtrack and reconsider its steps. And then there's the whole idea of training on retri data, showing the model examples of errors and corrections. And that seems to be really effective for improving its reasoning abilities.
And last but not least, even though fine-tuning existing models with retri data hasn't really worked out, creating this synthetic retri data, it can actually be a good workaround, especially when real-world data is hard to come by.
Exactly. So all these findings together, they really highlight how important error correction is for building these more robust and reliable AI systems, and they open up a whole bunch of new possibilities for the future of AI research.
This has been a really thought-provoking deep dive, but there's even more to come. In the final part, we're going to explore the broader implications of this research and discuss its potential impact on different fields. So make sure to stay tuned for part 3.
Welcome back to the deep dive. So we've been talking about this research on language models and how they can learn from their mistakes. But in the last part, let's take a step back and think about what all this means, like the bigger picture.
Yeah, for sure. This research, it's not just about making math problem solving more accurate. It actually challenges how we think about language models.
And how they learn and reason, like fundamentally.
So it's about more than just getting the right answer. It's about developing systems that can solve problems more like humans do.
Right, exactly. Like being able to recognize and fix errors, that's like a core part of human intelligence. It lets us learn from our mistakes and adapt to new situations, and it helps us understand complex stuff in a more nuanced way.
And this research is saying we can teach language models to do the same thing.
Yeah, that's the exciting part. By building error correction into the training process, we might be able to create AI systems that are way more transparent and reliable and adaptable.
You mentioned transparency a couple times. Why is that so important?
Well, if we want humans and machines to work together and trust each other, transparency is key. If we can understand how an AI system came to a conclusion, like if it can explain its reasoning and even acknowledge when it makes mistakes, then we're more likely to trust its judgment and feel comfortable using it.
It's like the difference between having a calculator that just gives you the answer versus one that shows you all the steps it took to get there.
Exactly. And this kind of transparency could have a huge impact on all sorts of fields, like education, healthcare, scientific research, even policymaking.
I could see how that would be helpful for education. Imagine if students could learn, not just from seeing the correct answers, but also by understanding how to find and fix mistakes.
Right, like imagine having AI tutors that can walk students through problems, point out common mistakes, and explain how to avoid them. It would be like personalized learning, tailored to each student's needs.
And in healthcare, you could have AI systems that help doctors diagnose patients and plan treatments. But they wouldn't just give recommendations, they would also explain the reasoning behind them.
Yeah, exactly. And that would lead to better decision making and hopefully better outcomes for patients. And in science, you could have AI systems that can analyze data, generate hypotheses, design experiments, and they could explain their thought process the whole way through.
Wow, it sounds like this research could really change the way we approach learning and problem solving across so many different areas.
That's the hope. But of course, like with any powerful technology, there are some ethical things we got to think about.
Like what?
Well, one big one is bias. We need to make sure the data we use to train these models is unbiased and representative. We don't want to create AI systems that discriminate against certain groups or perpetuate existing biases in society.
That's a really important point. We don't want AI to reflect the worst parts of humanity.
Exactly. We also need to think about how these advancements will affect the workforce and society as a whole. As AI systems become more capable, we need to make sure that everyone benefits and that no one gets left behind.
So it's not just about the technology itself, it's about how we develop it and use it responsibly.
Right. This research opens up all these amazing possibilities, but it also shows us that we need to be really careful and thoughtful about how we move forward.
Well, this has been a really fascinating deep dive. It feels like we're only just starting to understand what AI can do when it can learn from its mistakes.
Yeah, for sure. This research is just the beginning. As we continue to push the boundaries of AI, figuring out how to make error correction a core part of the training process, that's going to be essential if we want to unlock the full potential of these technologies.
And that's our deep dive for today. We hope this gave you some food for thought about the future of AI and how these systems can learn and reason more like humans.
Thanks for joining us. And if you have any thoughts or questions, feel free to share them with us on social media.
We love hearing from you. Until next time, keep exploring, keep questioning, and keep learning.